Well, learners, I hope you are doing well. Welcome to today's lesson, whereby we are going to be looking at geomorphology, grade 10 geomorphology. But before I start with today's lesson, I would like to ask you to please subscribe to my YouTube channel. Then when we are looking at the geomorphology for grade 10, we are going to start with the structure of the earth. We are going to look at the structure of the earth. Then what you need to understand in terms of the structure of the earth, you must know and understand that the internal structure of the earth is divided into three. So the earth consists of three layers. We have the crust. The crust, it is the outermost layer of the earth. And secondly, we have the mantle. And lastly, we have the core. But when it comes to the core, remember that I said we have three layers, which is the crust, the mantle, and the core. But when it comes to the core is divided into two. We have the inner core and we have the outer core. Then let's start by discussing the crust. As you can see again in this diagram, it shows the layers of the earth. This diagram shows that we have these layers of the earth, which is the crust, the mantle, the outer core, and the inner core. Starting with the crust. What is the crust? The crust, it is the outermost layer of the earth. If you have noted in the previous diagram from this picture, you can see that the crust is not thick as compared to the mantle, the outer core, and the inner core. So the crust, it is the least thick one in terms of thickness when you compare it with the other layers. Then the crust is the outermost layer of the earth. It ranges in terms of thickness. It ranges between 5 kilometers to 75 kilometers. Then the crust is made up of the solid continents and the ocean floors or the seabeds. They are part of the crust. Then crust make up only 1% of the total volume of the earth. Why does it make up only 1%? Because the crust, it is the less thick layer of the earth. That's why it only makes up 1% of the total volume of the earth, because it is less thick than the other layers. Then when it comes to the temperature of the crust ranges from negative 60 degrees Celsius to 200 degrees Celsius, where it merges with the mantle. So what you need to understand in this part is that, especially when it gets closer to the point where it merges with the mantle, that's whereby the crust has higher temperatures. Then the dividing zone of distinction between the crust and the mantle is known as the discontinuity line. So the dividing zone of the distinction between the crust and the mantle is known as the discontinuity line. The crust is less dense because it's less dense than both the mantle and the core. So as a result, the crust, it appears like it's floating. It is floating. It appears as if it is floating because it is less denser than the mantle and the core. Then when it comes to the layers of the crust, we have the continental crust and we have the oceanic crust. We refer to the continental crust as the seal. Then the oceanic crust, we refer to it as seema because it consists of silicon and magnesium. Then if you check from this diagram, from this picture, you can see the continental crust is the one that we have in our continents. And then when it comes to ocean, it is underneath, located where? Underneath the ocean. Then now let's discuss in detail the layers of the crust, which is the continental crust and the ocean crust. The continental crust, the main rock in the continental crust is granite, with dominant minerals of silicon and aluminum. As I've mentioned earlier, that we refer to the continental crust as Cl because it consists of the minerals, which is silicon and aluminum. Then in terms of thickness, the continental crust is about 30 to 60 kilometers thick. And then the Cl, which is the continental crust, is lighter and is therefore forms the upper layer. It is a continuous layer around the Earth. Then we also have the oceanic crust. The main rock in oceanic crust is the basalt. And main mineral for the oceanic crust is silicon and magnesium. In terms of thickness, it is about, or it's between 5 and 15 kilometers thick. The sigma, or the oceanic crust, is heavier and forms the lower layer. It is a continuous layer around the Earth and underlies the ocean, which means it's located where? Underneath the ocean. Then we look now at the mantle. The material that makes up the mantle is plastic in nature and is called peridotite. Then this is liquid rock, is known as molten magma. It is not rigid, which means that it is not solid. And it gives way under pressure because it's not solid. The high temperatures of the mantle ranges between 200 degrees Celsius and 3000 degrees Celsius, which results in the viscous nature of the magma. Why are we using the term viscous in nature? We are saying it is viscous in nature, which means it is fluid in nature. It is because of the very high temperatures. Such temperatures affects the fluid magma in that it generates convection currents, and thereby these convection currents supports the theory of plate tectonics. We are going to discuss this in my next video. This layer is about 1,950 kilometers thick, which shows that the mantle is also very thick and composes about 85% of the Earth's volume. So then this molten rock consists of mainly of magnesium and silicon. So it's thick. In terms of thickness, it is thicker than the crust. Now we look at the core. The core then is divided into two layers. It has the inner core and the outer core. Then average temperatures similar to the sun's surface, which means the temperatures are very high. It can be about 5,500 degrees Celsius. Then when it comes to this one, we have the outer core. What is the outer core? The outer core is liquid in nature, about 2,200 kilometers thick, consists of minerals containing gold, platinum. So such minerals became displaced to crustal regions during the Earth formation. That is why within our crust, in our Earth, we get such minerals. We get gold, we get platinum, and other minerals that were displaced during the Earth formation. That's why we then get these minerals within the crust region. Inner core. Inner core, unlike the outer core is liquid in nature, but the inner core is solid in nature. It consists of nickel and iron. Then it influences the magnetic field of the Earth. Then the inner core as well has a radius of about 1,350 kilometers. Then this is the internal structure of the Earth. The internal structure of the Earth consists of 3 layers, which is the crust, the mantle, the core, whereby the core is divided into 2 layers, which is the outer layer, the outer core and the inner core. So that's it. That's what you need to understand about the internal structure of the Earth. I hope you have enjoyed today's lesson. So please don't forget to subscribe to my YouTube channel.